Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Part 21 with matplotlib tutorial. In this video we will discuss about working with annotations. In this chapter, we will cover the following 15 things as you can see here. Alright, so let's get started. So here, first we will see a simple example, adding a title. Alright, now you can see the output. It's simply done with the pyplot title function, which takes one string as a parameter and sets the title for the whole figure. As you can see here. Now we will know about how to use latex-style notations. We can now annotate figures. However, in a scientific and engineering context, the solution demonstrated previously suffers from one annoying limitation. We cannot use mathematical notations. Or, can we? In this example, we are going to see how to use LaTeX to display mathematical scripts in a figure. Alright, just here we change the string. Now see here, this script does exactly what we did in the previous recipe. It shows a figure with a title at the top. However, as the title of the recipe might hint it, the title is rendered with LaTeX, allowing us to use mathematical notations. Let's execute it. As you can see the output, and note one thing, this LaTeX notation feature is not limited to titles, it can be used for any annotation. Here, we simply demonstrate this on the title text. Alright, now we will know about adding a label to each axis. After a title, a proper description of the figure's axis helps a great deal for users understand a graphic. In this example, we will show you how to get a label next to each axis of a figure. Now see here, Here we use the pyplotx label and pyploty label functions to add a description of the horizontal axis and the vertical axis, respectively. As for the pyplottitle function, this function accepts the latex notation. These functions are available for any kind of graphic. You would use the same functions to annotate a scatter plot, a histogram, and so on. Alright, now we will know about adding text. So far, we have seen how to set text at preset locations, such as title and axis. In this example, we are going to see how to add text at any location using text boxes. Now you can see here we use the pyplot text function that takes a position and the text to display. The position is given in the graphic coordinates, specifying the position of the left border and the vertical baseline of the text. Alright, now we will know about alignment control. The text is bound by a box. This box is used to relatively align the text to the coordinates passed to pyplot.text. Using the vertical alignment and horizontal alignment parameters, respective shortcut equivalents are VA and HA, we can control how the alignment is done. Bounding box control. The pyplot text function supports a bbox parameter that takes a dictionary as the input. This dictionary defines the various settings for the text box. So now here we declare the box. And here we just add the box. Now you can see here, alignment control with bounding box. Now see the following details. The dictionary passed to the bbox parameter defines the following key value pairs: face color, this is the color used for the box. It will be used to set the background and the edge color. Edge color, this is the color used for the edges of the box's shape. Alpha, this is used to set the transparency level so that the box blends with the background. Box's style, this sets the style of the box, which can either be round or square. Pad, if box's style is set to square, it defines the amount of padding between the text and the box's sides. So you can use following kind of parameters inside the bbox functions. Now we will know about adding arrows. Adding text boxes can help you to annotate a figure. However, to show a specific part of a picture, nothing beats the use of an arrow. In this recipe, we will show you how to add arrows on a figure. Alright, now you can see here, the pyplot annotate function shows text working on the same lines as pyplot text. However, an arrow is also rendered. The text to be displayed is the first parameter. The XY parameter specifies the arrow's destination. The XY text parameter specifies the text position. Similar to pyplot text, one can play with the text alignment through the horizontal alignment and vertical alignment parameters. The shrink parameter controls the gap between the arrow's endpoints and the arrow itself. As you can see here. Now we will know about how adding a legend. A proper figure is not complete without its own legend. Matplotlib provides a way to generate a legend with the minimal amount of effort. In this recipe, we will see how to add a legend to a graph. Now you can see here, each pyplot function has an optional label parameter to name an element, such as curve, histogram, and so on, of a figure. Matplotlib keeps a track of these labels. The pyplot legend function will render a legend. The legend is automatically generated from the labels. Alright, now we will know about adding grid. When preparing graphics, we might need to have a quick guess of the coordinates of any part of a figure. Adding a grid to the figure is a natural way to improve the readability of a figure. In this recipe, we are going to see how to add a grid to a figure. This script will show a curve with a grid in the background. The grid is aligned to the ticks of the axis legend. Adding a grid is as simple as calling the pyplotgrid function with true as the argument. A grid is comprised of lines, and as such, pyplotgrid accepts line style parameters, such as line width, line style, or color. These parameters will apply to the lines used to draw the grid. Now we will know about adding lines. When you have a very specific need in mind, the figures offered by matplotlib might not be of much help to you. All the graphics made by matplotlib consist of basic primitives. When demonstrating how to change the color of a box plot, we mentioned that most matplotlib plotting functions return collections of lines and shapes. Now, we are going to demonstrate how to directly use a fundamental primitive, lines. Let's see here, in this script, we plot 16 independent lines. The pyplotline2D function creates a new line2D object. The mandatory parameters are the endpoints of the line. The optional parameters are all the parameters we have seen before for line-based figures. Thus, you can use line style, line width, marker, marker size, color, and so on. The pyplotline2D function creates the line, but the line will not be rendered unless you explicitly ask for it. This is done using pyplotgca add_line. The pyplotgca function returns the object that is in charge of keeping track of what to render. Calling gca add_line simply signals that we want to render a line. The pyplot axis, scaled, function is required to ensure that the figure uses a uniform scale, the same scale as the one used on the x and y axes. This to be contrasted with the default behavior, tight, where matplotlib will give a different scale to the x and y axes to fit the figure as tightly as possible into the display surface. Now we will know about how to adding shape. To make your own figures out of basic primitives, lines are a good way to start, but you will most likely need more shapes. Rendering shapes works along the same lines as rendering lines. In this recipe, we will show you how to add shapes in a figure. Here we need to import matplotlib patches library. Let's see here, no matter which shapes are displayed, the principle is the same. Internally, a shape is described as a path called patch in matplotlib API. Paths for several kinds of shapes are available in the matplotlib patches module. Indeed, this module contains patches used for all the figures. As is the case for lines, creating a path won't be enough to render it, you will have to signal that you want to render it. This is done by pyplotgca @_patch. A lot of path constructors are available. Let's review those used in the example. Number 1, circle, this takes the coordinates of its center and the radius as the parameters. Number 2, rectangle, this takes the coordinates of its lower left corner and its size as the parameters. Number 4, ellipse, this takes the coordinates of its center and the half length of its two axes as the parameters. Number 5, fancy box, this is like a rectangle but takes an additional boxes tile parameter. Now we will know about how to working with polygons. Polygons are barely more complex than paths and are defined by a list of points. The matplotlib patches polygon constructor takes a list of coordinates as the inputs, that is, the vertices of the polygon. Now we will know about working with path attributes. All paths have several attributes that we already explored before: line width, line style, edge color, face color, hatch, and so on. Here, we use a non-filled polygon with dashed edges to draw a polygon outline without having to create several line objects. Numerous effects can be achieved by just playing with the attributes of a path. Now we will know about controlling tick spacing. In matplotlib, ticks are small marks on both the axes of a figure. So far, we let matplotlib handle the position of the ticks on the axes legend. As we will see in this recipe, we can manually override this mechanism. So here we need to import matplotlib ticker module. Let's see here, we forced the horizontal ticks to appear by steps of 5 units. Moreover, we also added small ticks, appearing by steps of 1 unit. To do so, we perform the 2 steps. Number 1, we get an instance of the axes object, the object that manages the axes of a figure. This is the purpose of ax equals plot.axes. Number 2, for the x-axis, we set a locator instance for both the major and minor ticks. Now we will see another example. Now see here, as shown previously, we can add a grid with pyplot.grid. This function takes an optional parameter, which it can accept 3 values, minor, major, and both. It determines at which ticks the grid should be displayed. Now we will know about controlling tick labeling. Tick labels are coordinates in the figure space. Although it makes sense for a fair number of cases, it is not always adequate. For instance, let's imagine a bar chart that shows the median income of 10 countries. We would like to see the names of the countries under each bar, rather than the coordinates of the bars. For a time series, we would like to see dates rather than some abstract coordinate. Matplotlib provides a comprehensive API precisely for this. In this example, we will see how to control tick labeling. We have seen the ticker locator to generate the location of ticks. A ticker formatter object instance will generate labels for the ticks. The formatter instance we have used here is a fixed formatter, which will take the labels from a list of strings. We then set the x-axis with our formatter instance. For this particular example, we also use a fixed locator to ensure that each bar is right at the middle of one tick. Now we will see a simpler way to create bar charts with fixed labels. Now you can see here, rather than using the ticker API, we use the pyplotsticks function to give a fixed label to a fixed set of ticks. This function takes a list of positions and a list of names as the parameters. The result is the same as the previous example, it's just shorter and easier to remember. Now we will know about advanced label generation. What if the point of the ticker API is that we have shortcuts around it? The ticker API can do better than show fixed labels for each tick, as follows. In this example, the ticks are generated by a custom function, make_label. This function takes the coordinates of a tick as the input and generates a string, here, a percentage. No matter how many ticks matplotlib decides to show, we can generate the right label for it. This is more flexible than giving a fixed list of strings. The only new thing here is func formatter, a formatter that takes a function as a parameter. Alright, so friends, our today's video was up to this. Thanks for watching the video, see you in the next video. Please subscribe our channel and don't forget to like and share the video. Thank you.